Hello, everybody.
Hi, everyone.
Yeah, thanks for joining. Today we will talk about APEX security. So if you have any questions at any time, please use the chat to just write it in there. We will watch over it and then answer the questions in the stream. And if you have like issues with your platform you're watching on, we are on multiple ones. I can recommend joining YouTube. That's in most cases the most reliable one. But so anything to say before we start, Kevin?
No, not really.
So let's dive in. So
Yeah, let's start straight away.
Going to share my presentation. So that's our talk, APEX security. We did it already at a few conferences. First about us. I'm Philipp. I'm from Germany. I'm product lead here at United Codes, and mostly do web dev and databases, of course. I have a history of doing consulting with APEX, and of course, then you need to be up to date with security. So that's how this talk was created.
Yeah, so my name is Kevin. I'm from Belgium, and I've been working with Oracle APEX for quite some time now. I'm a senior APEX consultant here at United Codes. I mostly do projects, but I'm also involved in some of our products. You can find me on different socials. And as many of you know already, I do love cycling.
Yeah, he does. You maybe have heard of us. We're United Codes. We do a lot of projects. Our most products, our most famous one is APEX Office Print for PDF printing. But we have a lot more we really want to talk about, but maybe later if you're interested. First, we start with our main talk. And for that, we have a big agenda. So first, we're going to introduce a little bit of theoretical stuff about security. Why it's important, but then the rest of the talk is mostly demos. So first we start with client versus server. It's really important to know the difference. Then session state protection. Maybe users can tamper with your inputs, etc. SQL injections is an important topic and probably the most famous one. and then cross-site scripting. At last, we will share some general tips and, of course, a Q&A, but feel free to just use the comments to ask questions anytime, and we see if it fits to the topic. We will answer it immediately or later. So yeah, starting off, in my research, I found this CIA triad. It does actually not have to do with the agency CIA. It's because of the abbreviations of first confidentiality, availability, and integrity. These are the three main reasons you want to care about security. First, like confidentially, if you deal with data, you have some important data, it's your value, and probably it's not open data in your company. It's that some people are only allowed certain parts of the data. You probably don't want to see to share the HR information with every employee, etc. So security needs to make sure that only the people allowed to can actually see the data. Availability, the next thing. You trust that your systems work. You trust that you can access your data, you can write to it. And for that, you need availability. So only when you plan an outage to upgrade the database, for example, it should be unavailable and not because somebody does a denial of service attack or something else. And the last one is integrity, meaning that your database is in a state that you leave it to. Nobody else can like tamper with it. You can just trust that it works in the correct way, and that the data is how you leave it and not tampered with. All right. So what can go wrong when some of these don't get fulfilled? First, system failure, misuse or abuse of systems. You can, of course, sabotage people. That's mostly that they don't even know that something is going on. Espionage is a huge thing. And for like smaller people, more interesting is like fraud or theft, that you can steal data to get some bitcoins or something. Or you can maybe fraud some companies into a service or something. So Kevin is now taking over. I will stop sharing my screen. Oh, that was too early. Yeah, your screen is now the shared one. Okay.
All right. So let's talk a little bit about scope for this session. So we will only cover APEX. That's why the session is called APEX Security Basics. Of course, besides APEX, there are a lot of other considerations to be aware of. We have non-technical things. People can leave their laptops unattended, have post-its with sensitive username or password data attached to their screens, things like that. On the other hand, there's also technical areas. We have security based on network level. We have operating system securities, updates, things like that. Certain settings on the web server that are vital to security as well. But this session will only be about APEX. If you want to read more about APEX security, then we can recommend the book of Scott Spendolini. It is already quite old, we should say, from 2013, but even today, it's still a great read. So if you want to learn more about security, then this would be the book to read. What also is important is knowing the architecture. So if you're using an APEX application, you're using a browser, of course. To access your APEX application, normally you would use HTTPS, so your connection to the server is secured, which has a positive effect on the amount of attacks that can be done. We have the mid-tier. Most of the time, it's Oracle REST data services, and it will function as a connection pool, basically, and it doesn't really host application logic. The application logic is actually available within a database tier. That's also where your data will reside in the Oracle database, of course. It's also where all of the Oracle APEX metadata is situated. And that is where your business logic and application processing will be done. So if we take a look about client versus server, what runs where? So on the server side, we have, of course, your SQL and PL SQL code. We also have server-side conditions, also authentication and authorization schemes. So logic implemented there that runs on the server. On the client side, we have things like JavaScript and jQuery. Exception here is the multilingual engine of the database, which can also execute JavaScript on the server side. But normally JavaScript will be executed on the client. If you have dynamic actions configured in your application, they do most of the time they are on the client side as well. Also, if you have hidden item types, they will be rendered on the client side too. So these are important things to know when you're developing applications. And basically what we say is that the client is the wild, wild west. And what do we mean by that? So users can disable certain things on their browser. So they can disable JavaScript, for example. They can execute JavaScript through the console. So it's always a good idea to filter sensitive data on the server. As I said, users can disable JavaScript or execute code in their console. So you should always check on the server if a user is allowed to do something. We also suggest that you avoid the JavaScript pseudo protocol in your links. So sometimes you have a hyperlink in your application and you want to execute some JavaScript code behind the scenes. We can do this by saying JavaScript and then our JavaScript function. But this, in some browsers, this generates a little URL in the lower left or the lower right side, and it makes it easy to see. It makes it easy to see for the end users which code is being executed. So try to avoid this as it enables users to execute code more easily. So we say that doing this by dynamic action is way more secure, for example. All right, let's go to our first demo. So we have an application here, and we see 3 input fields.
Could you zoom in a little bit? I think it's small.
Small, sure. Is this better?
Yeah, it's better. Thanks.
Yeah, okay. Okay, let me first show the page. So this is our page. And as you can see, we have a form region with a few input fields. Now, if we are the user, we can see only 3. We can switch our authentication to admin, and then we can see an additional credit card number and phone number field. Now, how can we do this? So this is the bad way of doing this, just to make this clear. So if you go back to our page, we can see that there is nothing really special going on in our form. There is a dynamic action defined on page load. And what does this do? So this dynamic action is actually fired when we are not admin. And what it's doing is it's hiding the credit card number and the phone number field. So this is why if we switch to the user, we don't see the 2 additional fields. So everything's okay on the screen, but really it isn't, because these fields are actually available within JavaScript. And we can use the APEX JavaScript API just to query the data. So if we use apex.items, for example, we can see here that we can see that there are several fields that we cannot see on the screen. So, for example, credit card number and our phone number, they are listed here. So if they are available within the JavaScript API, we can also get their value. So if we do apex.items and we say credit card number, not get validation message, but get value, then we can actually see the value of the credit card number as a user, even if we're not supposed to. And it gets even better. We can also set the value to something completely different. So now I've just altered the credit card number and I can show it too. We can even show the input field. And here's my credit card number. So it's really easy for an end user to tamper with these fields. Of course, there's no save button here, but if there was, a user could be saving your data even if he or she is not supposed to. So how can we fix this? We have a different page here. And as you can see, this is the same functionality. But if we go back to the console here, if I'm getting a list of the Apex items, there's no phone number or credit card number here anymore. So how can we do this? If we go to the page, there's no dynamic action anymore, but we've actually set the authorization scheme for this item. The same for phone number. So this item will only be rendered if the authorization scheme is met. So this is a much better way of doing things. A second example, it's more or less the same as the first one. So we have our form, our same form here. If we're the user, we cannot really do anything with it. And if we are administrator, we can delete this record. Again, if we go to the page, we can see that this delete button has an authorization scheme. So that's good. That's the way it's supposed to be. But if we go to processing, we can see that there's no authorization scheme selected here. So what does that mean? If we switch back to user here, and we should submit our page, so we can say Apex. So normally, if you have a form in Apex, there are 3 types of requests that are quite common: create, save, delete. So if we submit our page with a delete request, then even though the button is not here, we can still delete our user. Of course, this is not the way it's supposed to be. So how can we fix this? Let's have a look. So on the rendering side, everything is staying the same. We have the authorization scheme defined on the button, but we have the same authorization scheme also defined on the page process. And that way, a user cannot submit a page through JavaScript. This process will not be executed. So if we execute the same line here, so if we submit the page, nothing happens because the authorization is kicking in. So make sure that if you're using authorization for buttons or items, that you also add authorization to your processing, to your application processes. That's a very important thing to know.
All right, thanks.
All right.
I will move over. So let me share my screen again. Next topic is session state protection and / checksums. So first, what is this actually? And the goal is with session state protection or checksums to prevent users to change parameters when they are not supposed to. And the way this happens is like that next to the actual value that gets sent from the database to the website, they also send an additional value, and that's a checksum. And it gets computed via a cryptographically function, a hashing function, and that just makes some gibberish out of the value. But the thing is that you can't guess it. So like for every different value, there's a different checksum. And then when you, for example, change a value you're not supposed to, like just a read-only item, and then if you send it back, then the server does the same calculation again, checks the sent value and the sent checksum. But as you can't guess the checksum for the changed value, the server will know that you have changed the value and say, okay, I won't process this request anymore, and yeah, just abort it. So this was one example. You can use it to that's how Apex internally handles like read-only items to make sure that if you have it in a read-only state that you can't tamper with it. But there's a actually more interesting demo with URLs. So let's jump into here. And same app, so same concept here. We have user rights and admin rights. So as a user, I can see a few of the IDs, and you can see here are gaps, for example, ID 4, ID 10. But if I go to administrator, I can see all the employees. Here are no gaps in the data anymore. Okay. So as you can see here, I have sequential IDs as you showed you. So a smart user could go ahead and see, okay, I see 4, I don't see 5, I don't see 6. What will happen if I open this edit page? And then in the URL, and this is really small here, so I will just for now paste it here. This is the URL, right? Here we can see we passed the ID of value 4. So what if a smart person goes ahead and instead of using the 4, just change it to a 5? And that is what I'm going to do here now. Change this 1 to 5 and leave this page. And as you can see, it worked. I now see Liane, which I was not supposed to see. And this is bad, of course, because that's basically we trust that our reports here, that the links here, that only the people really seeing the row can click on it, right? Luckily, the fix is super easy. And if you go to your page here, page 12, that's the basically the report page, the form page. And then if you filter on security, then here is this page access protection attribute in here. And this is set to unrestricted. Please note that normally it should be enabled. So I manually actually disabled it. But really be careful in your apps that you set it to arguments must have checksum. There's also no argument supported, so that's for a page where you can't even pass a page item to it, and no URL access, but I'm actually not sure what this does. I have never had a use case for this. So we will just enable arguments must have checksum, and we go back to our report. Now we click this link, and now this link actually is way longer. So if I copy and paste this here, you can see, so this was just the length of the old value, so end session, but now there's a new attribute here, and CS, checksum. And this is, as I told you, a large string of gibberish, and this is just the cryptographic value for the 4. And if I now just tamper the 4 to a 5 in here, it will actually say, oh, yeah, the checksums don't match anymore. You still passed the checksum of the value 4. There has been some tampering going on, and so it will show me the error page. And yeah, that's how Apex has our back with security. Same thing happens for read-only item you're allowed to see, but when you try to change the value of the read-only item and then submit, you will also get this kind of error message, session state protection again. And interesting to know, in your shared components, there is under the security tab an entry called session state protection. And on there, you can see all the values that you have. For example, in this app, I had like 12 pages with arguments must have checksums, 2 with unrestricted. There I need to be careful maybe. And this can also be changed on the page item level itself. So you can disable it for a certain item or enable it to make it finely tuned to your needs. All right. Okay, Alan has a question. What if you use the standard process on the page and you want to differentiate users who can create from the other one who can't delete?
Yeah, so I think the question is because we showed the admin or the user, but what if you have 2 different users, like someone who can create certain records and another one who can delete certain records? I think we'll get to that part with the additional tips. That would require a role-based authorization. So if you have different users, you can assign different roles to them, and then based on that role authorization, you can align those with your processes.
Exactly. Like this is just a Boolean is admin or not. So
Yeah.
we have one authorization scheme, but you can finely tune it to is allowed to save, is allowed to delete. And then based on the data from the user in your tables, you can do a check if he's allowed to or not. But yeah, we will have some tips later on this.
Yeah,
but
exactly.
Thanks for the question. And now Kevin will take over again. So
yes. So another big topic is SQL injections. So SQL injections means that someone is able to insert malicious code into your application. So basically modifying your SQL statements. So how can we prevent this in our APEX application? It is always a good practice to bind your page items in your sources in APEX. So you'll see an example of this here. So the page items are bind in the SQL source. And you should always be careful when using dynamic SQL. So if you see some dynamic SQL anywhere, you must be, your brain should be cautious. So the first question you need to ask yourself is, do you really need dynamic SQL? Most of the times the answer is no, but some of the times the answer is yes. And then you need to consider a few things. So always a good practice is to manually validate your inputs. You can use bind values. For example, when you're using execute immediate within PL SQL. And you can always also use certain APIs like dbms assert or apex exec to execute SQL. So we have a little demo of this as well. So if we go to our application, so here we have this input, and we have this little report based on a PL SQL function. So it basically says, show me all the records which contains the character Y 6 times. And the operator field is playing a crucial role here. So if we go to the page, we can see our report, and it's using a function here. So these 3 parameters are provided to the function. And if we go and take a look at the function here, so the get quotes function with the 3 parameters, it is returning SQL here, or it is a SQL statement here, which is executed in PL SQL. And here the variables are just concatenated in the statement. So what happens if I put something, if I put a special operator here? So we can do something like this. So basically what it does, let me hide this. If we go to debug, let's enable debug here. So this becomes our SQL statement here. So basically, we don't get all the quotes that we need with the character count saying y bigger than 2 in this case, but we've actually added or 1 is 1. So we get every row out of the table here. And that is, of course, not what we want. Another example that you can do is change the operator with a union. And if we refresh this, of course, there are no records with the character y this many times, but we have selected also the data from the secrets table. And now we just get our usernames and our passwords here. So this is obviously not what we want. How can we do this in a better way? If we go to this page, we have the same select statement, also from a function here. But if we take a look at the function, it is actually the same SQL statement, but you can see here that we check which operators are allowed. And if the operator is something different than the ones that we want to allow, then you get an error that the operator is not allowed. We also use bind variables, which are escaped here, when using our execute immediate code. So if we try to execute this code again, we get an error saying that the operator is not allowed. So it's always, we can always recommend to escape your input and to check if you're using dynamic SQL. All right, I think back to you, Philip, for cross-site scripting.
Thanks, yeah. Let me switch the screen. All right. Cross-site scripting, that's often abbreviated as XSS, X for the cross. And that's similar to the SQL injections, whereas with SQL injections, you can, of course, inject SQL into the query execution. And this, with XSS, you can inject JavaScript into the page and of others. Then, because you don't want to run JavaScript for yourself, you could already do that with the console. But the goal is basically to let some JavaScript that you somehow entered into the page on other machines, for example, to steal the session token and get their rights, or if it's a banking app, you can send yourself money with that. So it's also like very dangerous to have such an vulnerability. So where can it actually occur? And somehow I did mess up my slides. Usually it's happening in packages. For example, if you use http.p and you just output some of the values you have in your database, and then some user typed some script type, for example, in there, then that will get shown. Or for example, in report columns, when you don't have escape HTML or escape special characters, then also this won't be happening. What's also possible is that in input fields in Apex, in input items, you have this restricted characters setting, and it's typically to all characters can be saved. But you can also, for example, set it to allow list for only characters, numbers, and spaces, or like just block list HTML characters. That can be really useful, but I'm also thinking it's better to don't have any vulnerabilities than make it your app not take these values. There are always exceptions with names where like some spaces, some specific characters are in there, and then you will run into issues too. So let's look at the demo here. And I'm still in this error site here. I can't see back button. Okay, XSS. So here I just have a form, and I'm the malicious user, can save some data here. And maybe on some different page, another user has a report with the same data, like here, like the user that I'm going to update, or like some dynamic content here that also shows some information. So what I can do is now change the first name, and it could be any input on the app. It just has to be like displayed somewhere else, and then script, and then I will just call alert. That's JavaScript for show a pop-up message, XSS, and then I can close this again. And now if I save, this site submits, reload, and you can immediately see there's something going on. I have this alert box here saying XSS once, twice actually. You can see here, interestingly, the input box still shows it correctly because inputs are treating the value differently. They're not showing it as HTML. But where interestingly here, the classic report and the dynamic content region, they don't show the script tag. Why? Because if we look into the HTML, they treat the value as JavaScript. So it's a script tag in HTML. So the browser thinks, oh yeah, here's some JavaScript I need to execute. That doesn't work. Doesn't matter. You have to trust me. And so it's not even showing the characters itself. So now how can we fix this? How can we make this secure? And luckily, it's fairly easy, really. So first, on the classic report column here, you search for escape special characters. You enable that, and that's done. For the dynamic content region, this is an example for anything you do with PL/SQL. Here I select the first name from my users table, and we can just change this to calling apex escape.html and pass the first name here. And then Apex will automatically change the angled brackets to an escaped version that basically tells the browser, I want to display this symbol, but don't treat it as HTML. Okay, save the page, run it, and nothing happens, no box anymore. And now we can finally see also the text of it by just basically, you can't actually see it in here. It's still showing the text, but it's like a semicolon and GT for greater than semicolon. That's the code, the HTML code that tells the browser, I want to show the symbol, but don't treat it as HTML. So yeah, that's the demo. Now we have some additional tips.
Yes, we do. So the additional tips, we can use database features for added security. So for example, we can use multiple schemas, and we can only grant the necessary rights to other schemas so that your data will be safe. There's also something called virtual private database, which is actually a security feature within the Oracle database. And it basically enables security on row level. So what it basically means is that users will only be able to see the data that they're allowed to see based on a role they have in the database. So when SQL gets generated, it essentially adds a where clause to the statement so that a user is not allowed to see data that they that might be in the table, but has a different role assigned to it. There are a few scanners to monitor your APEX application for security breaches. So there's the integrated APEX advisor. I think in the new version of APEX, I don't know when it's coming, but the APEX advisor will be will get a new version. So the APEX advisor has been there for quite some time, but it will receive an update normally in the next version. So that is definitely something that we could recommend. Then there's APEX Cert. I think there's a new version released already. So these are just a few security rules that check your APEX application. And then, of course, you can also use APEX Project I, one of our projects, which has all the security rules enabled. So you can scan all of your different applications for security breaches. And there's a lot more functionality to enable security features within your APEX applications available in APEX Project I. So I would recommend you guys to definitely check that out. You can also set up single sign-on. So that would be a central way of authentication. It's a way of having less passwords, and it's a safer way than just a username and a password for each and every separate application. So that's also a good thing to implement. And then there's also smart authorization within APEX, and I think this is actually the thing that the question from Alain is referring to. So you can have different rights. For example, you have an admin user, but also a read-only user, for example, or someone who has a few privileges, but not as much as the admin user. You can define those rights yourself. And then you can assign those rights to roles, so different roles, which you can assign to users. And by doing this setup, you get a really flexible way of organizing authorization within your APEX applications. And APEX provides out-of-the-box functionality for this kind of setup. So if you go to your application, into shared components, there is, under security, there is application access control. And this allows you to create roles, assign roles to users. There are views you can use to query certain rights or certain roles, or which user has which role. And you can also enable security or authentication features on every component within the application, within the page builder. So this might be a great way to start with different authorization schemes. Another thing is logging. We implement a lot of logging in our projects and also in our products. So basically, logging, you can add logging everywhere. If you do inserts, updates, deletes, if you have certain business logic, it's always a good idea to add some logging or even debug messages in APEX. So you can actually see what is going on, and it's a lot easier to debug or have a look where the problem can reside when you have logging enabled. There's this great open source library called Aura Open Source Logger, and you can find it on GitHub. So that's a great way to start with logging in your APEX applications.
There's a great follow-up question by Alain. So yeah, that also means you need to split the insert and delete process, so you cannot use the standard form process. And yeah, that's completely right. So normally, if you generate a form with APEX, and this is on authorization on separate authorization controls for insert and update and delete. If you generate a default form, you get one process for insert, for update, for delete, the same process. And for that one, you can only put one authorization scheme there. So if you need different authorizations, I think you can just duplicate that one form control thing, the process, and then there's a checkbox inside it. So you say, I allow to use inserts, allow to use updates, and allow to use deletes in this one. And you can just duplicate it, untick like insert from the first one, and the next one untick delete, and then set different authorization schemes. Or you just roll your own insert statements or packages and have separate processes that way too.
Yeah, you can always write custom PL SQL code which takes into account the authorization scheme that you are using.
And to be fair, like table APIs are way quicker to implement with AI assist nowadays, luckily. But yeah, it's sometimes tedious. All right, moving on. Infrastructure. This is now moving a little bit out of the Apex code or like taking in servers, etc. But if you have an admin, then nudge him to really patch your Apex environment, your database, your auths endpoint. There could always be huge security issues. And if a patch is out, also the vulnerabilities down. So yeah, stay up to date. Use HTTPS. I think that's luckily nowadays a no-brainer. It's fairly easy to get a certificate. And that way, all the requests are encrypted, and it's hard to do like sniffing attacks in between and to know what's actually network traffic, what data is transported in there. Third one is security headers. I think that's not well known, but basically there are HTTP headers you just set up in your web server, and these allow you to specify, for example, certain domains, for example, apex.oracle.com, you allow this one to load JavaScript from. And then if some hacker, for example, finds some XSS and tries to load a JavaScript source from maliciousite.com, it's not in the list of the allowed domains, and then it won't execute. And there are a lot more. There are rules for inline scripts, for images, etc. You can really fine-tune this, and that way you are actually more assured that nothing can go wrong. And in newer Apex releases, also Apex, I think, is playing with this. I think actually they will implement some inline script hardenings on this one, that this will have security headers out of the box. And maybe the demo I showed before, where you just add a script tag, won't work in the future. That would be cool, right? And production. Don't develop in production. I mean, it's if you're a super small shop and you have 5 users, okay. But if you're an enterprise house, don't do it. If you're a developer, you need specific rights to see data that basically, as a developer, you want to see the view as admin, as this guy, as this person. So you have to play around. And in prod, you shouldn't have these rights. And if you need to manually quickly enable something to test it out in prod, then others can see it too. It's not the place where you just change on an open heart surgery, etc. What I've seen a lot is keeping copies of apps in prod. It's just, oh yeah, I do an upgrade and let me quickly do a copy of it so I'm sure. That's fine during the upgrade process, but like if you leave these copies there, that's could be risky, because if you have an issue in that version, you just forget about it, it's there, and people can still find it. You can easily scan for apps with the alt URL, F*P, you can just iterate the numbers, you find every app that's on your environment, you find these outdated app, and maybe you like the new app has different security settings, so the old ones doesn't work anymore, but so lets people see stuff they're not supposed to or something. Just, it's dead weight, just remove it, keep it out of prod. Code, best thing is keep it simple, stupid. The more complexity or the more code you write, the more errors you can make. It's easier said than done, but it's true. You don't probably have to reinvent the wheel for everything. For example, a lot of times you can use cool Apex APIs that are supported, that are programmed by experts, and that you don't have to maintain. What's really nice is to do pull requests with code reviews, so that anytime anybody changes something on a important system, that just another person looks over it, and then 4 eyes just see more than 2, right? Also with AI generated code, that's becoming a bigger and bigger thing. They're really great at coming up with code in a fast time. And the thing is, like, even if they get better and better, most of the time they are right. But then if we trust them too much, there are still machines that can hallucinate. Sometimes they make really weird stuff. Maybe they compile, but maybe they're super flawed. So you should treat code written by a real human differently to one by an AI-generated code. Just like if you know, and you should be open about, I wrote this code with the help of this one, then your colleagues maybe have to check it really more thoroughly than otherwise. Alright, that's a thing we quickly forget. It's so easy to create a REST endpoint to let some other system, some other user just fetch some data. But it's also a point of security issues. Really make sure all your endpoints require authorization. This could be tedious, but like a really simple if statement in the start of your auth handler package, for example, with an API key already does the job. It's you can't have open API endpoints that allow to read sensible data or even write data. So make sure, just go through the list of all the endpoints and check if they are secured. Rate limiting is also a good thing. Unfortunately, it's not as easy to do this, but basically this says that a certain user, like from his IP, should only use the service like 100 times per 10 minutes or something. Of course, you have to adjust this to your needs, but otherwise, if people like can basically send thousands of requests, they don't have anything good in mind. They try to find vulnerabilities, and by slowing them down, you will make your life easier. OWASP top 10. This is like every few years, this committee releases the top 10 issues and points of web security. And you can see here the most recent one are still from 2021. Probably there's a new one coming out soon, or maybe there is in the last few months. I haven't checked anymore. And you can see like 2017 injection, broken authentication were huge issues. And today it's still broken access control, so that you have access control, but you haven't validated in a long time, and still people could do things they should not do. Injection, insecure design, misconfiguration. So just read through them when you have a bit of time, and then you get like it's an eye-opening thing where when you next time see anything, you might think, oh, I could have an issue with broken access control here, and then maybe you find something. All right, enough slides. Thank you very much for attending. And so this is your last chance. If you have any questions left, please use the chat to ask them. And in the meantime, small advertisement. Next week, same time, we will do another United Codes Live. This time I will be talking about practical AI in PL/SQL made easy. I have some fun demos, and we will make cool things with PDFs, with tools, with reasoning, etc. And you don't need to have AI knowledge before that. I want to show you that it's really easy to use AIs from PL/SQL, and you don't need Python or something else. Yeah.
Yeah, I think it's a great session to look forward to.
Thanks. Yeah, so I don't see any questions. Oh, Alain, thank you very much for the feedback. He says, great presentation.
Yeah, I hope, although it were security basics, but I hope, that everybody at least learned something or got a few ideas how to set up their security better, or just be a little bit inspired, maybe. That's at the end the goal of these sessions.
Even it's the basics, most of the time we you can't forget it, but it's the most important ones to follow. And if you're in the rush, it's it's easy to forget them. Okay, we got a question. Joseph, what is the best way to see a list of odds endpoints? Luckily in Apex, if you go to SQL Workshop, and then there's this RESTful services section here, and here is this modules. I just have this example one, and here you can see each endpoint. I think like here you can see a list protected by privileges is off here, but this is just the odds typical security and rules. But of course, if you use here, okay, this is a get, but you could use PL SQL and then have a package that it still could have security endpoints, so you can't always trust this info there. I like to have like one central package actually where all the endpoints go through, and I can do central logging, central authentication, checking, etc. Yeah, and then I want to have the access control in there.
Yep, very convenient. I think you can also, if you have SQL Developer, you can also have this same overview.
Yeah, I think too. The web and both the client, right? Yeah.
Yeah, exactly.
All right, I think no more questions. So yeah, we can end the stream. So thank you very much for tuning out, showing up, and see you in the next one.